So case 2 of trigonometric substitution. So if this is present, okay, u squared plus a squared. Case 1 was u squared minus a squared. Okay, so let u be equal to a times tangent theta. Okay, so y tangent, no? So u squared plus a squared. So meaning from Pythagorean theorem, so it must be the sum of the squares of the two sides, no, the opposite and the adjacent sides. Okay, so u would be on um, the opposite side. Okay, so if this is our triangle, then the opposite side is here and the adjacent side is here. Okay, so we can put the u here, the differentiable function of x. Okay, and the a here. So meaning the hypotenuse would be, okay, square root, no, of u squared, okay, plus a squared, no, from, again, Pythagorean theorem. The hypotenuse is equal to the square root of the sum of the squares of the other two sides of the right triangle. Okay, so if we're going to get the relationship of the opposite and the adjacent side, that's opposite over adjacent. Okay, so meaning tangent, no? So katawa, so tangent is opposite side over adjacent side. So the opposite side is u and the adjacent side, no, is a. Okay, so that's for tangent, tangent, no, theta. So meaning u therefore is equal to a times tangent theta. Okay, or if you cannot recall, then again, you can draw the right triangle, then analyze, no, the relationships of the sides of the right triangle so that you can make this equation, no, substitution equation, just in case you cannot recall right away, no, this equation. Okay, so for example, if we have this, integrand. So if we have an x squared here and square root of x squared plus 16. Okay, inside the radical, no, is x squared plus 16. Okay, so we do not have a um, formula, no, for this. So we use trigonometric substitution. Okay, so we draw, no, the triangle, the right triangle. Again, if you tend to forget the substitution, the equation, so back to the basics. Okay, so you draw the triangle. So I'm changing the orientation. Okay, from case 1. Okay, the orientation of the right triangle was different so that we can we can be reminded, no, we'll be reminded of our trigonometry. Okay, so the opposite side would kaning contain, no, the variable x. Okay, so if this is in the form u squared plus a squared, okay, so meaning, no, u is x and a is, okay, 4. Now square root of 16 is 4. So the opposite side of the triangle, okay, of the theta here must be the variable x, and the adjacent side is the constant 4. So meaning, okay, the hypotenuse is square root of x squared plus 16. Okay, so from this right triangle, we can get the relationship of the opposite side and the adjacent side. That's tangent, no? So tangent theta is x over 4, or x is 4 tangent, okay, theta. So if, for example, okay, you interchange the x and the 4. You used 4 for the opposite side and x for the adjacent side. So you can use uh, cotangent, no, actually. So adjacent side over opposite side. Okay, 4x over 4. So that's fine. Okay, but it would be easier if we will be dealing with tangent, no, instead of its reciprocal. Okay, pero in terms of whether it's correct ba, okay, or not, so of course, okay, it's correct. But it would be easier to use tangent, no, instead of cotangent. So after solving for or setting the equation for x, so we solve for dx. Okay, so that's 4, no? Derivative of tangent is secant squared. Okay, so 4 secant squared theta d theta. So let this be our equation 1, this as equation 2. So we need the square root of x squared plus 16. Again, we need, okay, another side of the triangle to form the trigo function. And it must be the, what they call this, the constant. Okay, the side containing the constant. So it's square root of x squared plus 16. Okay, and divide it by 4. So it's a ratio of the hypotenuse, no? And 4 is the adjacent side, no? This is the opposite side. So over the adjacent side. So this is hypotenuse over adjacent is the reciprocal of cosine. Okay, so meaning this is secant. Okay, theta. So square root of x squared plus 16 all over 4. Okay, is secant theta. Okay, or square root of x squared plus 16 is 4 secant theta. So that is be equation number 3. So we'll use these 3 equations, okay, to transform this into trigonometric functions so that we can integrate using the formulas, okay, or the solvable groups of trigonometric integrals. Okay, one of the methods discussed previously. So instead of writing dx now from equation 2, so we write 4 secant squared theta d theta and then divide it by x squared. So instead of writing x, we write 4 tangent theta and we square it. And square root of x squared plus 16 is 4 secant theta. So multiply it with 4 secant theta. Okay. So we can now simplify the integrand. Okay, so this is 16. Okay, 16 tangent squared, no, theta. Okay, times 4 secant theta. So that's, okay, 4 divided by 4. So we cancel out the 4s. So we have 1 over 16, no, for the constant. So 1 over 16 and then divided, times, not divided by, times the integral of, so we have secant squared, okay, over tangent squared and another secant at the bottom. Okay, so simplifying, we get secant theta, okay, and over tangent squared, okay, theta. Okay, so secant and tangent squared. Okay, so we cannot directly use the solvable groups of trigonometric integrals. Okay. So we can, however, no, transform tangent squared into in terms of sine and cosine, and also for second, no, the second function, we can write it as 1 over cosine. No, the reciprocal of second is cosine. And then for tangent, that would be sine over cosine, no, from the ratio identities. So sine over cosine. Okay, but we need to square these. So basically sine squared, no, and cosine squared. And of course, the d theta. So if you're stuck to trigonometric functions, no, one of the methods is to transform everything, no, into um fractions containing cosine and sine, and then factor out whatever is common, okay, or cancel out whatever is common, okay, and see if you can already use the formulas, no, in solving trigonometric functions. So, in simplifying a complex fraction, so we multiply the numerator with the reciprocal of the denominator. So, it's cosine squared theta, okay, over sine squared theta. So, we have cosine squared over cosine. Basically, that's only one cosine na lang on top, okay, and then divided by sine squared. So, you can either um put the sine squared no on top, okay, or just treat it as it is, and then we can transform that cosine over sine into cotangent, and we can write the other fraction, okay, it's 1 over sine, which is equivalent to cosecant. So this is cotangent and cosecant. So there's a formula, no, to integrate, okay, cosecant, or rather this is cotangent, no, theta, and this is cosecant theta d theta. Okay, so integral of cotangent cosecant is negative, okay, cosecant theta, right? So this is equal to 1 over 16 times negative cosecant theta plus c. So don't forget to return, okay, or restore the original variable. So cosecant theta, okay, cosecant is the reciprocal of sine. So it's hypotenuse, no, over opposite. Okay, so let's write here or at the bottom na lang. Okay, so cosecant is, so let's put it at the side. Cosecant theta is again hypotenuse over opposite side, no? So the hypotenuse of the right triangle above is square root of x squared plus 16, and the opposite side is x. Okay, all over x. So we'll replace cosecant with this expression. Okay, so it's negative, no? 1 over 16, okay, times square root of x squared plus 16, and then all over x. Okay, wait, all over x plus c. Okay, you can write it as that fraction, or product of two fractions, or you can also write it as one fraction. So x squared plus 16, square root of x squared plus 16 all over 16x, okay, plus c. So this is the integral of, okay, the given is dx over x squared Okay, square root of x squared plus 16. So that's for the second case. Okay, if u squared plus a squared is present.